All right, so we're going to practice the skills associated with the imaginary numbers lecture. And just have some rapid fire practice. All right, and reps are everything in math. Now, you want to improve your computational skills, then you got to practice just like anything else you do in life. You got to practice whatever it is that you want to get good at. All right, so we've established that -1 to the 1 is -1, -1 to the 2 is 1, -1 to the 3 is -1. Each time you multiply a number by a negative, you change the sign of the quantity produced. Okay, so hopefully you're seeing this pattern. So -1 to an odd number is -1, -1 raised to an even power is +1. We have established that the square root of -1 times the square root of -1 by definition is -1. And it's easier to write the square root of -1 as I. So I times I is -1, and that's what you got to remember. I squared is -1, which means that there's another name for -1. It's I squared. And I squared to the 1 is -1. I squared to the 2 is +1. I squared to the 3, -1. I squared to the 4, +1. I squared to an odd exponent gives you a negative sign. I squared to an even get you +1. And that repetition, I hope, has helped you move the needle forward a little bit. All right, so these are the types of problems that cause the most difficulty for students when they get started with this computation. It's a non-textbook approach that I'm going to take here, and I do so because I think it hits the rules of exponents, and some students don't know their rules of exponents, and this might help them learn them. So what's another way of writing 2i to the 7th? Is 2 times I squared. That's not the best 2 in the world I've ever written. And how many times does I squared fit into 7? I guess you got to divide 7 by 2. So I squared 3 times gets us I to the 6th, and we need to multiply by I to get I to the 7th. What's another name for I squared? Another name for I squared is -1 raised to an odd power times I. And -1 to an odd is equal to -1. And 2 times -1 times I is -2i. Okay, so I did that one, and now you can pause the video and try these 4 problems, and I'll just do them because you have the power of the fingertip to stop the video and practice for as long as you want or as little time as you want. I'm just going to do these problems, and you remember to stop the video if you want to practice. -4i to the 55th, I could have written as I squared. I got to divide 2 into 55. 27 times gets me 54, yes, times I, which is equal to -4 to the -1 to an odd power, times I. -1 to an odd, -1. So this is -4 times -1 times I, and I hope you can see that is 4i. So what's another way of writing -4i to the 55? It's easier to write it as 4i. All right. Now we'll do 9i to the 103, which is 9i squared to let's see, 51 gets me to 102. I need one more. Looks like it's another -1 to an odd. -1 to 51. If I did it 51 times, that would get me 9 times -1 times I, which is equal to -9i. All right, so I think I just did that one. Now we're going to try -6i to the 40th, which is equal to -6 times I squared. 2 goes into 40 20 times. That's -1 to an even. -1 to an even is 1. And -6 times 1 is -6. Now we'll try 9i to the 23rd. 9i to the 23. Like I said, I'll leave that parentheses. which is equal to 9i squared. What, 11 times gets me to 22 times I, which is equal to 9 times -1, 11 times I. That quantity is -1 to an odd, so it's -1 times 9 times I, which is -9i. And now I'm going to change the 23 to a 25. And do one more problem. 9i squared, now it's 12 times. That gets me to 24 times I. Ah, well, that's 9 to the -1 to an even power times I. Well, that looks to me to be 9 times +1 times I. Or simply put, 9i. Okay, so you'll see one of those problems on every test until the middle of May. And you're going to get about 12 tests. I have a feeling by then you'll be able to do this and maybe even remember it when you go to your next class. All right. What's the next problem with i's? Well, we got to learn how to multiply, because textbooks actually use this skill quite a bit. So let's look at 5 plus 3i times 2i minus 1. Oh, anyway, I'm so used to doing quadratics here. 5 plus 3i times 4 minus 2i. Now let's see what that becomes. All right, 5 times 4 is 20. 5 times minus 2i is minus 10i. 3i times 4 is 12i. And 3 times minus 2 is minus 6. And I times I is I squared. Okay, so that's 20 minus 10 plus 2i is positive 2i. And minus 6 times I squared, we talked about that in the video. That is equal to minus 6 times -1. So what does I squared do in a multiplication? Changes the coefficient sign. So that's really 12 plus, that's really plus 6. Okay, so we have like terms, 20 plus 6 is 26 plus 2i. Pretty straightforward stuff. So now we'll do just 2 more of those. Because we'll be doing that skill with binomial squaring and conjugates. So in fact, we can practice that skill with conjugates and actually do 2 skills at the same time. So you're trying to learn how to do 3 minus 4i over 5 plus 2i. How to rewrite that. All right. Mathematicians don't like imaginaries in the denominator, or haven't liked it over the years. And this is why. Oh, sorry, I meant to do the reciprocal. All right, here are 2 quantities. All right, which one does your brain work better with? Dividing 2 by an imaginary? You know, when you want to try to define what that is, and I'm not sure I can. I mean, I could talk about it, but it's odd. Whereas cutting an imaginary in half, we're used to dividing things by 2. Okay, so what we want to do is we want to get the imaginaries out of the denominator. And the conjugate for 5 plus 2i is 5 minus 2i. 5 minus 2i. Now, why do we do that? Because the middle terms always cancel. So I will do this multiplication out. First, we'll do the numerator. 3 times 5, 15. 3 times minus 2i, minus 6i, minus 4 times 5, minus 20i, and then positive 8i squared. Divided by 5 times 5, 25, 5 times minus 2i, minus 10i, 2i times 5, positive 10i, positive 2 times -2, minus 4i times I squared. All right, so what happens in the denominator? Those middle terms cancel. So the next time I use a conjugate, I'm not going to do that. I know they cancel. All right, and we're going to do 2 or 3 of these. So definitely that cancels. What happens with the I squareds? Well, I squared turns positive 8 into -8. So therefore I have in the numerator, minus 26i, like terms, and positive 8i squared becomes minus 8. And I hope you know what minus 4i squared becomes. Positive 4. So that then becomes a fraction divided by a nice number. And 15 minus 8 is 7. And that's minus 26i. And you probably see those on your SATs. So even if you're not going to become an engineer, you want more options at the college level, you want to learn how to do this. Okay, so let's practice that a couple of times. Yes, indeed. All right, so let's look at 4 plus 3i. And let's divide that by 9 minus 2i. Okay, so you're pausing the video, you're trying to conjugate this so that the imaginaries disappear. So, oops, sorry, got to multiply by the conjugate, which is 9 plus 2i. That gets rid of the middle terms, 9 plus 2i. All right, and so I've got 36. I've got 8i. I've got 27i. I've got 6i squared. In the denominator, I'm getting 81. I mean, you square that and you square that, you're going to get 4, and 81 is 85. So 81, middle terms cancel, I get minus 4i squared. Okay, so what do I get in the denominator? There's your 85. We can do this in our head. 36 minus 6 is 30. Remember, that's going to become negative 6. Yes, I'm changing the sign. And 8 and 27 is 35. I suppose I should divide everything by 5 here, reduce this fraction. Common factor is 5. So we've got 6 and 7i. And 5 goes into 85, I believe. 117 times, I believe. Okay, so probably should do that, but we're just really practicing this skill right now. All righty. One more of those. And I trust that if we're going to do them on every test until May 15th, and we're in the middle of January, I hope you're fine. All right, 4 plus 5i over 7 minus 3. Let's do plus 3i. Conjugate. Multiply by 7 minus 3i. 7 minus 3i. 49 and 9 is 58. So our denominator is going to be 58 if you're looking for patterns here. 4 times 7 is 28. 4 times minus 3i is minus 12i. 5i times 7 is 35i. And we have a minus 15i squared, which is going to become positive 15, all over 49 minus 9i squared. Well, there's our 58 in the denominator. I said it would be that. 28 plus 15, 38 5 is 43. And minus 12 plus 35, 35 minus 12, 25 minus 2, so positive 23i. Okay, hopefully I'm not making any mistakes there. All right, what's another skill that we have associated with this? Well, we want you to be able to, I want you to certainly be able to square a binomial quickly. So let's just practice that. 4 plus 5i squared. Now, some of you will need to do parentheses times parentheses. I hope you do, because if you're not sure how to do this more quickly, you should do that. But what you will find is you're squaring the first term. You're doubling that product. That's 20i, so you're doubling it. And you're squaring the last term. I don't care if it's plus or minus. When you square it, you're going to get a positive, and you're going to get I squared as well. So 16 minus 25 is minus 9 plus 40i. Okay, and you're going to get until the middle of May to get that right. Okay, another one. Let's do 5 minus 3i. And remember, you're stopping the video. I'm just going to do it. Square the first term, double the product, minus 30i. Square gets you positive 9i squared. 25 minus 9 is 16, minus 30i. Let's do another one. Let's do 4 plus 7i, parentheses squared. All right, square the first term, 16, double the 28, gets us 56i. Square that, gets you 49i squared. So take 16 away from 49 and change the sign. believe that's minus 33 and 56 up. All right, there's your practice for that. One last type of problem that I hope that we can get a little practice with is the graphing form for a quadratic. 2 times x minus 3, that's a great 3, Jim. X minus 3 squared plus 9 equals 0. So we have a quadratic whose vertex is 3, 9. And if you think that that quadratic is hitting the height of 0, well, I think you're imagining things. We talked about that in the introductory lecture. Imagining a sign change and figuring out what those two x values are. All right, so let's do it conceptually first. So I've got something here plus 9 equals 0. Well, I guess this term has to equal negative 9. So I hope you can understand that has to be true. Then addition of 9 becomes what on the other side? I hope you say subtraction of 9. I didn't write subtraction of 9. I did now. And so therefore we are now here. And I hope you can see that 2 times something equals negative 9. Well, then that something in this box had better be negative 9 divided by 2. So the 2's cancel and I get negative 9, may be written as negative 9. Interesting. I hope you understand why this is the next step. I'm not going to do this for every problem, so feel free to rewind or move that. Rewind. I just dated myself. All right, if something squared equals minus 9 halves, I hope you can see that this has to be plus or minus the square root of minus 9 halves. You can see that squaring a plus or a minus gets us the positive, and squaring a square root gets us what's inside. So therefore, your next step is x minus 3 equals plus or minus the square root of negative 9. And the square root of negative 9 halves is the same thing as the square root of 9 halves times the square root of negative 1. And what's an easier name for the square root of negative 1? Taking that minus sign and writing I after the radical sign. Last step. X equals subtraction of 3 becomes addition of 3. I suppose I could write this as 3 over root 2. And I could rationalize that, but we're going to leave it as that because we're really looking at the process here. And I lost a little bit of the screen there. So let's do another one and see how you do. And I'm just going to write the inverse operations on the right for practice, and you come back to this particular one and replay it if that didn't make sense. So let's look at a negative. Let's look at negative 3. Let's do x plus 5 squared. And let's put this below the x-axis, minus 7 equals 0. Okay, I hope you do what first? Subtraction becomes addition. Multiplication becomes subtraction. Squaring becomes plus minus the square root of negative 7 over 3. And we move the negative outside and call it I. And then addition of 5 becomes subtraction of 5, and this is purely mechanics. Now, for those of you who are curious, this was a cupcake down. We are at negative 5, comma, negative 7 for a vertex. And we're trying to hit a height of 0, which is the x-axis. Y equals 0 is the x-axis. And so what are you looking at here with a term of negative 3? You're looking at 3 numbers, negative 5, negative 7, and positive 3. And how many numbers are you seeing over here? I see all those 3 numbers. You might want to pause the video and see if you could have, from the picture, written that answer, because that's going to be on every test until the middle of May as well. So you might well start thinking about what's going on. And to help you with that, I'll give you a picture and see if you can write the answer. And then you can do things quicker than the quadratic formula in certain instances. So let's talk about 4, let's talk about 5, let's talk an a value of 2. You pause the video and see if you can find the roots, which is when this quadratic equals 0. And I'll just write the answer. 4 plus or minus the square root of 5 over 2, imaginary. Let's find out why. And I didn't think about that, so I hope I didn't make a careless error. 4, 5, and 2. 4, 5, and 2 means x minus 4 squared plus 5 equals 0 is what we're solving. So let's solve that. See if it comes back to this. I hope it does. Otherwise, I have to make a decision whether or not I have to can this video and start all over again. I don't want it. All right, so positive 5 becomes negative 5. Multiplication by 2 becomes division by 2. Squaring becomes plus minus the square root of 5 halves imaginary. And subtraction of 4 becomes addition of 4. And you can leave it in this form. And I do believe it brings us back to that. And I'm tired. So those are all the I's that we're going to be throwing your way here this week. And I hope this little practice moves the needle forward for you. All right. So much for that. Test on Friday. And we got several days of practice ahead of us on about 50 different types of problems. All right. See you soon. Stop the video.